So in this video we'll be talking about odds. Now, odds and probability are related, but they are not really the same thing. And kind of for odds, we can really talk about odds in two different ways. We could talk about odds in favor, or we could talk about odds against. So let's begin by talking about what odds in favor of an event E might be. Well, the odds in favor of an event are also a fraction, but a fraction where the numerator is going to be the number of ways that the event can happen, and the denominator is going to be the number of ways that an event cannot happen. So kind of, for example, you may have heard someone say that the odds of a coin flip are just being 50-50. And so mathematically what this means is that the fraction 50-50 is just going to be 50 over 50. So that's how we would actually write that mathematically. Now, sometimes you may see that fraction written using colon notation. Now, colon notation is when instead of writing the bar between the numbers on top and bottom, we use a colon to separate the first number being the numerator, the second number being the denominator. Now, what this would actually mean theoretically in terms of our probabilities and counting and events and those kind of things would be that the 50-50, that if we flip that coin 100 times, we should get 50 times that we're landing on heads and 50 times that we're landing on tails. So the number of heads that we get, the event occurs 50 different ways. The number of ways that the event does not happen, so the coin lands on tails, is also going to be 50. So colon notation is actually useful when we're talking about more complicated proportions in general. And so one example where you might see this in everyday life is when you're talking about fertilizer. On a bag of fertilizer, you may see something like 5 to 5 to 5 written in the colon notation. Now, what that actually means is that the first number is going to be the number of parts of nitrogen that are in that fertilizer. The second number is the number of parts of phosphorus, and the third number, the number of parts of potassium in there. Now, those are all in proportion, so how do we get fractions out of that? Well, the 5 to 5 to 5 means that we have a total of 5 plus 5 plus 5, or 15 total parts. And so the 5 in the first position means that 5/15 or 1/3 of that fertilizer is going to be nitrogen. The 5 in the middle, the number of parts of phosphorus, gives us a fraction of 5 over 15. So it's also 1/3 of that bag is going to be phosphorus. And finally, the third 5 is being the number of parts of potassium. Well, that gives us 5 over 15 total parts, or 1/3 of the bag also being potassium. So kind of looking at our coin flip example again, when we say that the odds of landing on heads is 50-50, or we have a 50-50 shot of landing on heads, the 50-50 means that we have 50 plus 50, or 100 total possibilities, with 50 of those times being the outcome that we want, where we land on heads. And so the probability of getting heads in that case is going to be 50 over 100, or 1/2. So let's kind of go back and look at our spinner example again. So we've got our numbers 1, 4, 5, and 8. In the sample space, we had the numbers 1, 1, 1, 4, 1, 5, 1, 8, 4, 1, 4, 4, 4, 5, 4, 8, 5, 1, 5, 4, 5, 5, 5, 8, 8, 1, 8, 4, 8, 5, and 8, 8. So we had 16 different possibilities. The event that we talked about in that video was where we had the number was going to be divisible by 11. And so our set E actually consisted of the outcomes 11, 44, 55, and 88. So of those, the number of ways that E can happen is just going to be 4. And the number of ways that E can't happen is going to be the remaining 12 that we have left in there. And so that the odds in favor of E are going to be 4 to 12, or we can simplify that to 1 to 3. So to kind of see how that simplification might work, we start off with our ratio 4 to 12. Well, that's going to give us 4 plus 12, or 16 total parts. So the fraction that we have from that one is 4 over 16, but that fraction simplifies to 1/4. The 12 would then give us the fraction 12 over 16, and that will simplify to 3/4. And since the denominators are the same in that case, we can just say, well, 1 plus 3 is going to give us 4. And so that would be the same. We can just kind of look at the numerators as being the numbers that would be in our new proportion. And so for the first number, we would replace it with 3. For the second, we would replace it with 1. And for the second number, we would replace it with 3. So our proportion 1 to 3 gives us the same fractions as we would have with the proportions 4 to 12. And so that's why we end up saying that 4 to 12 is equal to 1 to 3. So we said at the beginning that we can talk about the odds in favor of an event, or we can talk about the odds against an event. And we said the odds in favor of an event are just going to be the number of ways that it can happen to the number of ways that it cannot happen. Well, the odds against of an event, we just flip those around. And we say that the odds against are just going to be the number of ways that it cannot happen to the number of ways that it can happen. So suppose we've got an example where we're drawing balls out of an urn. And inside this urn, we've got 5 red balls, 4 green balls, and 6 yellow balls. If we let E be the event that we draw a green ball, then we can ask 3 questions. What are the odds in favor of E? What are the odds against E? And what is the probability of E happening? And so the solution, we know that we've got 5 red, 4 green, and 6 yellow, which gives us a total of 15 balls in this urn. So the number of ways of actually getting a green ball are going to be 4, because we've got 4 green balls. The number of ways of not getting a green ball, well, there are 11 in there that are not green. And so our odds in favor of getting a green ball would be 4 to 11. Flipping that around, the odds against getting a green ball would then just be 11 to 4. So our probability, we've got a total of 4 ways to get green out of 15 different balls in the urn. So the probability of getting a green ball is just going to be 4 over 15. So let's look at an example where we know that the probability of an event E is going to be 0.41. So we can ask, what are the odds in favor of E? Well, the solution for that, since our probability of E is going to be 0.41, as a fraction, that's just going to be 41 over 100. Now remember that the numerator is going to give us the number of ways that E can happen. So E can happen in 41 different ways. We've got a total of 100 different ways. And so the number of ways that E can't happen, we just subtract. 100 minus 41 is going to give us 59. And so there are 59 ways that E cannot happen. So our odds in favor of E will just be 41 to 59. Now, whether or not we give the odds in favor or we give the odds against an event pretty much just depends on which is bigger, either the number of ways that it can happen or the number of ways that it can't happen. The bigger number will always, or we'll usually write that one as being the first number. And so the reason for this is because we kind of like to write the second number as being a proportion to 1. We want to have 1 as that second number just because it's easier to visualize in that way. So from that last example, when we had the odds in favor being 41 to 59, if we were actually giving those odds, we would probably give the odds against, because the number of ways that it can't happen is larger. And so we would probably give the odds against as being 59 over 41. So the question is, how do we make that second number 1? Well, we do that by remembering that our 59 to 41 is really just a fraction. So 59 to 41 is 59 divided by 41. Well, if we put that into the calculator, it's going to hand us something that's approximately 1.439. And so in the denominator, if we want to, we can make that the same thing with the denominator of 1. So our 59 to 41 as a fraction is 59 divided by 41, which is approximately 1.439. And we can write that as 1.439 over 1, or in our colon notation as 1.439 to 1. And so if we were talking about odds in this particular situation, if we knew that the probability of E was 0.41, then we would most likely say that the odds were going to be 1.439 to 1 against. So this has been a little bit of an introduction to using odds and talking about odds and what odds are and how they're related to probability. So I hope you enjoyed this, and I will see you all next time.